Alright, time for another DraftScience video presentation. Alright, still on the subject of the kinetic energy theorem. So I've decided to post a Quora, post. Let's see how long it lasts, all that kind of stuff. Who knows what's going to happen. We'll see what kind of responses we get. So we got one so far, and it's just insensible rubbish. So we'll just see. This argument should be over. I just can't believe the world is this irrational. I mean, I've pointed out to you the horrible history, that this thing was just made up. And when it was made up, it was 100% wrong. I mean, numbers where it'd say the thing had 200 when their new modern theory says 100 is the right answer. Newton says none. Newton says the whole thing is crap. And they kind of pretend it's somehow this is Newtonian or classic mechanics, when no, it's completely part of your new modern made-up physics, because it has no credibility. I mean, it's nothing but some sort of, they say it's some sort of mathematical formula. There's no even coherent mathematical formula. They're all convoluted derivations, where they end up, doing things that they would never do if they were calculating something else. I mean, it's so flawed and so wrong and so not producing any kind of real results in the real world. There's absolutely not any physical experiments demonstrating it to be true. Now, Stephen Bro's trying to engineer some. I mean, he already did the experiment, essentially, the best way you can do it, using springs and shooting them into springs, which is really good. And he already got the answer, which is, yeah, the theory is stupid. But he wants to prove that the stupid theory isn't stupid. And so he's going to try to figure out some way to do a fake experiment, to do a Ken Wheeler and show his little Pharaoh cell magic. But that's all there is. There isn't any real evidence anywhere. I can't even find somebody else trying to fake an experiment. I mean, there's no evidence for it. None. Not a single physical experiment ever conducted in 350 years showing us this kinetic energy formula being correct. Not one. No trains, no physical real trains, no physical anything real ever doing what they say. Nothing. And I have to make this aggressive an argument. Pleading for what? You just to concede that silly shouldn't be in the middle of physics? And you don't agree? No, silly should just stay there right in the middle of physics? Oh, well, whatever. It's just too stupid. Alright, so I say, is there any physical evidence defending the kinetic energy theorem? Yeah. Well, I should have said that better, right? Anyway, well, I should have said something, can anyone provide any physical evidence defending the kinetic energy theorem? The theory says that an 8-pound bowling ball will produce twice as much energy as a 16-pound ball thrown with the same force. Now, we've already seen, right, in my videos that that's actually what physicists tell professional bowlers, and professional bowlers believe it and try to, make it happen. Because they believe that's what physics says, and they believe physics is right. So they think there's some purpose in trying to make the 8-pound ball do it. Or the 10-pound ball. And they have no success, though. But we know that's what physics says. At least some part of conventional physics clearly says it. That's what the end result will be. That if you put your force or your energy, the same amount of energy, into an 8-pound ball, you'll get twice as much energy. At least half the professional physicists say that. And that momentum is always conserved, which sort of means there's momentum in the force, and that momentum can't just disappear. It has to go into something's movement, and then it can be turned into heat. Or it can go directly into heat. But the point is, it always has to go somewhere. Alright. And that's just a fact. No pro bowler can make a lighter ball work. Why? Okay, so we did get an answer. So this Ian Doggerly says, I'd wager that's incorrect. Well, you'd lose the wager because, I mean, frankly, because, yeah, there's a whole bunch of physicists that say that. We could just do the Professor Lewin video over and over again, and I can, you can keep betting badly, and I'll keep winning the bet. Let's say we're talking about kinetic energy. Duh, that's the subject. Ke equals 1/2 mv squared, right? Or Ke equals 1/2 vmv. Yeah. Let's write it in its real natural form, just so we can see how stupid it is. Anyway, if we assume that the boulder exerts the same amount of force, yes, that was a condition right in the statement, that's true, over the same amount of distance, who cares? We're not talking about any distance, doesn't matter, it's a force. The force goes into the object. How long it takes for the force to go into the object, who cares? None of that stuff's going to make any difference at all. It's an amount of force. But anyway, over the same distance on each bowling ball does the same amount of work. Yes, that's correct. Then both balls have the same kinetic energy. Well, that isn't true. And it isn't even true by your own bullshit. Clearly in Professor Lewin's demonstration, the heavier object moving half the speed with the same force in no way has the same kinetic energy. One has twice as much as the other kinetic energy. So you could just keep asserting that the physical reality is a certain way, but you have no evidence supporting that assertion. Okay. Then both balls have the same kinetic energy. No, they have what is in fact the same momentum. That's what the evidence clearly shows. So, what am I supposed to say? You're right? No, you're not. And there's no evidence supporting that statement, just none. All right, anyway. The 8-pound ball will be moving square 2, so I don't know what that means, are about 1.4 times faster than the 16-pound ball. Well, if it's going 1.4, by my calculations, that doesn't work. They can't have the same kinetic energy then. If the 16-pound ball is going 8 miles an hour, and then you have an 8-pound ball, to have the same kinetic energy, it has to be going 6, well, that's the same momentum. It'd have to be going 16. Yeah, I got to square that, I guess, right? So we got to do 12 squared, 144 times 8. Well, I'll have to go out and figure that out. But anyway, so this is just contrived, this 1.4 number. So we know in the experiment it doesn't leave at that 1.4 times faster thing. It goes twice as fast. I mean, again, do I really have to keep playing the Professor Lewin video over and 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 over? I mean, we'll just play the ending,
Whew! On the button!
Yeah, so on the button. Okay. There's your numbers. Twice as fast, twice as slow. The heavy object's going twice as slow. Not 1.4, twice. So, what? Anyway. So, and just logically, you could say, how could I possibly screw up getting the momentum into a bowling ball, right? So, at one point, they're arguing that the heavy ball, somehow, it doesn't get the energy. I go to throw the heavier ball, and it doesn't have the same kinetic energy. Somehow I screw up, and I'm not able to get the force into the ball. Now they're saying the 8-pound ball is weak. Now it's the 8-pound ball, somehow I can't get the momentum into it. I can't get it to go. Somehow, even though I'm throwing it faster, my arm's moving twice as fast, somehow the ball's not going to go twice as fast because my arm going twice as fast doesn't mean anything. Somehow none of that happens, even though it does happen. So, there's not much you can say. 8-pound ball we're moving for 1.4 times the 16-pound ball. Though, because both mass and velocity affect kinetic energy. I mean, what kind of, yeah, both mass and velocity affect momentum too. Surprise, surprise. To different extents, as you can see in the formula. Oh, isn't that amazing? I can see it in what formula? You didn't provide any formula, so that doesn't make any sense. But clearly you haven't demonstrated that there's any physical evidence, okay, that objects leave the same force with different amounts of momentum. They leave the same force with the same momentum. Because frankly, a force is momentum. You know, I'm sorry, physics. No, none of your physics teachers were, could figure that out. But I mean, that's what a force is. It actually is momentum. Energy is momentum. If you see something that's hot, it's got momentum in it. If you see something that's moving, it's got momentum in it. It's always the momentum. Energy is momentum. And it also is mass times velocity. E equals F equals mv. They all equal each other. Anyway, the only way you get the 8-pound ball to have twice as much energy as the 16-pound ball is just to throw it like you're, he says the only way, right? But we know the right way to do it is just to throw it. Throw it with the same force, and it has to go twice as fast. And Professor Lewin overtly says it. You can't fuck with momentum. Okay, would be if you did twice the work on the 8-pound ball that you did on the 16-pound ball. So I have to do twice the work on the 8-pound ball. I have to use twice as much energy to throw something lighter. Does that make any sense to anybody? No. Using the same force like in your question. How can I use the same force and apply a different amount of energy? I mean, even that. I have to use twice as much energy, he just said. I have to use twice as much energy, but I'm using the same force like in your question. No. Alright, using the same force, you would have to apply the force longer. So somehow it's how long your arm is swinging has something to do with it. And if I made my arm swing longer, which it really can't do that, right, and go the same speed, how could I possibly throw the ball farther by moving my arm slower? Taking a longer time to move my arm won't be helping me any. Then you did the 16-pound ball. So this is just gibberish. I mean, it's just absolute gibberish. What is there to say? All right, so then we get the arrogant, little, obnoxious, pretentious pile of crap signing off statement that all of these pretentious douchebags end with. It sounds to me like you've confused something in your calculations. They aren't calculations. I'm just taking the testimony of science. That is, I played the video where science says lighter balls have more kinetic energy. Science said it. I didn't say it. Science said it. I didn't do the calculation. Science said so. So why don't you just say, oh, those are terrible scientists? Why don't you go on all those videos that say those kind of things? Momentum is always conserved. Why don't you sit there and tell them they're full of shit? Why are you pretensively telling me I'm confused about something? When you don't have any evidence, you didn't show my confusion by showing me something called a piece of evidence. So anyway, not like the concept of kinetic energy is incorrect. So, it sounds that way to you. And based on the non-physical evidence you didn't show. So you have absolutely no evidence for your assertions. They're not in any way reflective of the question. So you're saying the question of why professional bowlers don't use lighter bowling balls is because lighter bowling balls don't produce more kinetic energy. Even though theoretically they have to if you're going to conserve momentum. So you're saying momentum is not conserved. So unlike these, at least half the physicists, see, they say there's no controversy, but apparently there is, right? Because certainly Physics Girl said momentum has to be conserved. She said it. And Lewin certainly just said it. So, I mean, how many do I pile up on one side before you take the controversy seriously? Professor Lewin isn't a high enough stature physicist, so his dissension from your belief that momentum doesn't have to be conserved, that somehow, you don't have to address it. Seems to me you have the same controversy you had 300 years ago, and you're just pretending it doesn't exist. But anyway, yes, so I responded with a comment, because at least you're allowed to do that. You have to click on this, which I do not understand. Where did the other guy's comment go? There was another person's comment, but apparently that's gone. No, it's here. So it said one comment by me, but the other guy's comment. All right, so this smart green guy says, especially when conservation of momentum at the pins comes into play. What the hell? So now there's conservation of momentum at the pins. So the pins have to obey conservation of momentum, but the bowler doesn't. You know, the bowler can lose half of it. The bowler's energy can disappear into nothing. You know, but not the pins. No, they'll be obedient. That change from 1/2 mv squared to mv hurts. So somehow he thinks that actually happens. That somehow momentum moves the pins, but kinetic energy moves the ball. What? You're really this crazy. You people are really this crazy that you think it's force when my arms are moving, and then it's kinetic energy when the ball's rolling down the alley, and then it's momentum when it hits the pins. You really think that's how the universe works? That somehow those three things, my moving of my arm, the bowling ball rolling down the alley, and the pins moving, that somehow they're all controlled by some kind of different formula? There's some sort of different force or energy that makes it happen? The energy is fundamentally different when it's in those different forms? Oh, too silly. Alright, so I said, I am seeking real physical experimental evidence. So I put that in quotes. Real physical experimental evidence of any claim made in defense of the kinetic energy theorem. Yeah. You claim that the same physical force can produce different momentums. Can you provide any physical experimental evidence? Question mark. I can provide countless videos where highly prestigious scientists say exactly the opposite. And then so I linked to the Professor Lewin little clip. A clip that's been done in every college classroom, you know, pretty much forever. Okay, they all do it. They all have an air track just for this experiment, you know, an oscillating experiments. But it's pretty much the only thing to use the damn thing for is this experiment. So we'll see what happens. We'll see how this evolves. So I guess I'll take a pause. Still, this, you know, it's not my, you know, I take, you know, garbage clothes. And so, you know, I don't like football much. Raiders, smaters. You know, I didn't even know they still played football, frankly. Anyway, I don't know if they still do. Yeah, so anyway, I go running in the morning, so it's the running suit. Anyway, so till then, later, we'll see if I have anything to add. Because, you know, maybe I'll just keep these videos on this, you know, just on what happens in Quora, and we'll just leave those as distinct, standalone little hunks of crap. So, yeah, so I'll pause. Pausing now. Yeah. All right, back. So let's go to this related question. So at least it starts off right. Is there any experimental evidence? So again, that's what we're looking for. That kinetic energy increases 4 times if the speed is doubled. Please do not give mathematical proof of kinetic energy equation. So, you know, he's seen the routine, right? So he wants a real piece of evidence, but that probably won't be provided, right? We can already guess. All right, obviously, is there experimental evidence? Okay, so he says obviously, and then he says imagine. Okay, yeah, that's real experimental evidence, that imagine stuff. Imagine 2 equal size soft clay balls flying towards each other at equal speed. If one is flying at 2 meters per second right, 1, 2, they hit each other mid-air and fall to the ground right in the middle. that actually doesn't quite happen, like I said. So again, it's not a real physical piece of an experiment, right? So we're not seeing the two clay balls do exactly what he says, because they don't do exactly what he says. There's all kinds of spinning and twisting. So what happened to the kinetic energy? Energy can't be lost, right? Yeah, did you measure the energy? So this is, again, it's not a physical experiment. He's just telling us how hot the clay got. He's just going to tell us. Okay, it really got much hotter than you think. Okay, momentum say it got this hot, 100 joules. He says it got 400 joules. You know, but he didn't put a thermometer in it. So there's no evidence. Right, all that energy right before the collision has now turned into heat energy inside the two balls. Well, first it moved pieces of clay, so let's not confuse the truth. First, little pieces of clay moved inside the clay, and that then turned into heat. So just like the pitting the bowling ball into the pins, first the ball moves the pins, then the pins bang into the wall and bang into the floor and spin on the floor and do all kinds of stuff where they transfer their momentum into heat. You know, sound, right? Lots of sound, you know, and certainly lots of vibrations that eventually end in heat. Okay. It does matter if those two balls were thrown at 2 meters a second on the wall or at each other. The energy got translated. So again, what does this have to do with providing any obvious physical evidence? No obvious physical evidence. Now, what if we watch the same scene from a train that is co-moving with one of those at 2 meters per second? So now we're going to play a relativity game, like somehow the collision doesn't happen because we're moving the collision. No, it doesn't make any difference. Alright, now the ball we are following has no kinetic energy anymore with respect to us, but so what? The other one has all of it. So it doesn't matter. You can't change the energy, because the energy is just something you see when two opposite things hit each other. Alright, the other ball is now moving twice as fast. How much energy does the ball have for us from the point of view of the train? Twice as fast means 4 times as much energy, right? It doesn't matter. You're squaring the velocity, so it doesn't matter which one has the velocity. Okay, if the 8's over here and an 8's over there, or whether 16's over here and 0's over there, it doesn't matter where you move the number you're squaring. Duh. Well, anyway, we see the same collision happening, both balls falling to the ground. Same result as before. The two balls contain the same heat, and so this isn't, again, this is all responsive to the guy's question. Do you have any evidence that there's more energy than what the momentum would account for? I mean, he should have said, demonstrating that that momentum is wrong and kinetic energy is right. Do you have a single experiment showing momentum failing to get the right answer? Maybe I should have said that too. Wrong. Now those two balls on the ground still contain kinetic energy for us, since they are moving relative to with respect to us. We could hit them with the train, for instance, which takes the energy and stop the train a bit further. Okay, again, it doesn't change. This relativity argument is just mush. It's just a distraction. It doesn't have anything to do with the fact that you have two numbers and you can just switch which one has the velocity. This just couldn't possibly matter. You're not changing how much velocity by playing relativity games. The two balls on the ground are both moving 2 meters per second with respect to us. And again, yes, they're doing that in a state where they're not transferring any energy to anything else. So essentially the energy is invisible because it's not active. So like the compressed spring, you can say something has energy, but you have to go find the original source of it, where the electricity is really moving, so to speak, where the rubber's hitting the road is where the action is. Everything sitting in the car isn't doing any acting. Okay, so before the collision we had one ball moving at 4 meters per second. After the collision we have the heat energy from the collision that was equal to two balls moving. So again, how could it can't possibly make any difference? So he just provides a relativity argument that has nothing to do with the subject. Only one ball moving twice as fast gets us 4 times the energy. So you still have the same amount of energy no matter whatever game you want to play with relativity. It doesn't change how much energy there is, either kinetic or how much the energy by momentum is different. You can't change any of it with a relativity argument. So what douchebag put, you know, sorry. Okay, he doesn't have a, usually they have a whole bunch of crap here about, you know, who they are. So that guy doesn't have anything. And he got, you know, somebody thumbed up at this piece of crap answer. Let's see. No comments? I don't know. This is an ad. Alright, so here's Tom. He's a BS physicist, Stanford University, 1988. So, experiment. Alright, so he can't link to anything, so he's going to tell us the experiment again. Lift an object to height h, then drop it. Measure the time it takes. So again, they're measuring the time it takes to hit the ground. Why don't they just measure how much it weighs when it hits the ground? That's how many joules it has. Its weight when it hits the ground is its joules. It's its energy. Time it takes to hit the ground. Repeat this experiment for different heights h. This experiment will provide evidence that a 2-fold increase in falling time t corresponds to a 4-fold increase in height h. You know, for example, you might measure these values as t and h respectively. So again, the point is demonstrating it with an experiment. So again, the guy overtly asked for physical evidence, and overtly that is ignored, and he's just given theoretical mush. Okay, so now if we make two observations, if we assume constant acceleration due to gravity, then we know that from g equals g dt that the 2-fold increase in the falling time corresponds to a 2-fold increase in the impact velocity. The work required to lift the object to a height h against the constant force of gravity was directly proportional to the height h, and by the conservation of energy, this work is equal to the kinetic energy at impact. So let's understand again that their understanding of work is, is if I move something to a position, I did work. But if I hold it at that position, somehow I'm not doing work. Obviously I am. Anyway, thus, combining our experiment with the above two observations, we have experimental evidence. So isn't this amazing? He doesn't even understand what the word experimental evidence means, where you actually have to do the experiment. That's what an experiment is something you do. It's not something you talk about. It's something you actually do. You know, he didn't say any thought experiments. I mean, come on. We have experimental evidence that a 2-fold increase in V corresponds to a 4-fold increase in kinetic energy in gravity, right? So you didn't prove it anywhere else. Gravity is a constant force. All these other forces, kinetic balls, all these other things, it isn't some sort of constant force. So just more horrible crap. That got 6 upvotes, by the way. So completely unresponsive to the question. 6 positive. Good answer. I mean, shit. The simplest direct experimental approach with no reliance on any formula is based on Kurt's answer. So who's Kurt? Was this Kurt? No. It's based on Kurt's answer. This wasn't Kurt either. Okay, so I don't see no Kurt. Alright. So I don't know what that even means. The method below relies on direct equivalence of thermal energy and kinetic energy. So, yeah, where's this going? I mean, what does that even mean? I mean, as I've already stated, you know, yeah, they never really teach you this, but kinetic energy it always has two choices. Energy always has when something's moving, it has two choices in terms of what can happen. It can hit something, make it move. And so now the energy is in this object, or it can do that, make a sound, or it can hit something like a wall and you can go into heat. But it's always going to end up that way, in a sense, right? If this thing hits something else and then this thing starts heating the environment, it's still the end result is heat. So it always kind of goes through motions, and heat is always the place energy sort of dies, in the sense that it's the place that you have to collect heat and then funnel it back into motion again. So it's the smallest, it's the It's not these, well, smallest is the, it's sort of a tricky, it's the chemical thing. You're driving the energy back into its simplest form, which is just electrons and atoms moving. Anyway. All right, so the simplest direct experimental approach. This is just, so he just didn't answer at all. He's not providing any evidence. Set up the experiment where you can impact one clay blob into another. So again, it's the same clay nonsense where who did the experiment? He's saying, is there any evidence? And this guy's just describing how you might make evidence. But somehow no one's ever bothered to do it. So he's just telling us what the outcome of the experiment is, even though he didn't do the experiment. I mean, it makes no sense, right? So he's just sitting here giving you all this stuff. Okay, you can measure the speed with double flash exposure on a camera and a variety of other means. So nobody's done these experiments. He's going to outline an experiment and then nobody's done it. Directly measuring the speed makes your experiment independent of any formula related to height or speed. So again, he asked if it's been done, and the simple answer is no, we have no experiments defending any of this horseshit. So instead of just saying the same. And then look, there's a Newton thing in here. Let me see what it is. Your experiment will allow you to determine your own formula for these variables without standing on the shoulders of Isaac Newton. So again, he thinks the kinetic energy theorem has something to do with Isaac Newton. When I've told you the history is its inventor was the guy who stole Newton's calculus. Newton's worst enemy in life is the guy who invented this horse shit, this unproven theory. I measure the temperature increase afterwards. If the impact is twice the speed, the temperature increase will be 4 times more. So we have no evidence that that's true, that you can get any more temperature than the momentum will provide. Momentum moves things. That's all there is. Momentum creates the heat. You can't make more joules of energy than what the momentum has in it. The weight, the pressure is all you have. You can't make no 4 times more. You can't. There's no free heat. Just like there's no free energy. There's no free heat. Okay. Ideally, this should be done in an evacuated glass tube. Yeah, ideally it should be done by physicists, who spend billions of dollars doing all kinds of silly shit. Well, maybe they ought to do this. Maybe they ought to put a thermometer in the fucking clay. Oh, I mean, this is so lame. Okay, none of the above results to use any formulae. So again, it just keeps saying how, it's completely not responsive, right? I mean, he's basically saying, no, I can provide no physical evidence defending this mush. Okay, you don't have to use clay. The temperature increase will go as the square of the velocity, regardless of what you use as an impact or a target. So he's just basically making a rubber stamp. Just every experiment you do will always prove us right, even though we never did any of the experiments. I mean, just amazing. You should use a ball bearing or some squishy rubber or 2 lumps of lead. Clay would be better as it's homogeneous, and has a huge bias for velocity. Anyway, and the dissipated heat will spread uniform through the material. Do you have any evidence for that even? Nope, no evidence. Reducing experimental errors due to non-uniform heating. So somehow he's just told us that that heat transfers through clay really well. Does he have any evidence that's true? I mean, certain clays, you could use certain kind of putty on your CPU to, make it more thermally conductive. But is that true of all clay? Anyway. It does matter if the impactor bounces a bit. Oh, so we have a concession that maybe the experiment won't be exactly as you claim it to be. Oh, okay. There will be some optimum time to measure the temperature after impact. So it's just a whole description of an experiment that obviously has nothing to do, again, with the guy's request for you to provide him evidence that the experiment has been performed, and you already have conducted the experiment and already collected the evidence. See, once he sees somebody else has done the experiment, now he doesn't have to worry about the question anymore, because you proved it. The whole point is for 350 years you're claiming something and you never prove it with anything called good evidence. Okay. So that's a different, I guess that's one of those ads or something. Human and population science. Popularization of science. An advocate of the popularization of science. Isn't that quaint? What kind of science? You mean your religion? Oh, okay. Even if it drops out of a thought experiment. So again, just more crap. Let's assume that so the guy just basically saying, don't give me formula, don't give me crap, give me a fucking experiment, and they do exactly the opposite. Alright, so let's assume that the object is a ball of putty, so they just keep going back to this crap, no real world examples, nothing to do with show me the 8-pound ball knocking down fewer pins. I mean, that's what it's supposed to do now, right? That's the new theory. So what? Do you think the differences between kinetic energy, 1/2 the mass times velocity squared, and momentum energy? Yeah, that would be what he's talking about. There is no KE or PE thing that exists independent of mathematics. So here we go again. There's no experiments. Physics doesn't happen in a physical world. No, our science has nothing to do with the physical world. It's mathematics. We don't care about what the real world's doing. We're just playing with our little numbers. It's cute. It's like little blocks, A, B, C, D, B, little blocks, and you play with your little blocks, and, they're not science. We don't do science. We just play with our little blocks. Okay, which is both how we define it in the first place. Okay, definite. That's what it's, look, it's D-E-F-I-N-I-T. It's definite. All right. Define it. Oh, okay, it's 2 words. Okay, define it in the first place. I mean, I got some fucking troll message from the software here. I posted my comment, and because I used my little ... thing, to kind of end a sentence that I want to kind of continue, they didn't like that. So I had to edit it. But they didn't make him fix that. Okay, and how we measure it. We measure speed and mass and discover the PE is the relationship between the two that is conserved. So again, they don't think momentum's conserved, they think kinetic energy is. Hilarious. And that KE is a relationship that is not conserved. So now he says kinetic. This guy says kinetic energy isn't conserved. So he would argue that the 8-pound ball does have more energy. Alright, the best experiments to see the difference is the different sort of damage projectiles of different masses and speeds due to targets. So again, he's going back to just watch bullets. Bullets do a lot of damage, so they must have a lot of energy. So to do it exactly the wrong way. Okay, don't look for real physical evidence. Don't look for scientific evidence. How fast or far a bullet or cannonball makes its target move, and how much force is applied to the target. Yes, that would be great if you did that. If you caught the bullet or caught the cannonball. Not let it go penetrate, in clay or some other kind of mush, that has some medium that has a bias against things going different speeds. So if you caught it with springs, then you'd have a great experiment. But you're not really suggesting that. Will increase only the relation to mass times speed, momentum, not kinetic energy. Will increase only in relation to mass times speed, momentum, not kinetic energy. So again, he's somehow saying momentum isn't a real thing. While the amount of energy that is released or given off is as heat or sound, and some of the deformation will be in proportion to the kinetic energy and will increase by 4 with the doubling of the speed. Yes, this sort of shit is measured all the bloody time. So he just said it right there. It happens all the time. We do the experiment all the time. We've seen it all over the place. And he won't give the guy a link. He won't show him the experiment where this is demonstrated. So it's just more of this horse shit that we've proven it. We did it. It's a well established by evidence. Not a single fucking experiment. I haven't gotten one link from these bullshit troll assholes pointing me to anything like a good experiment that demonstrates this extra energy. Either that the lighter thing has extra energy, or that the heavier thing lost energy. So they can neither show me one experiment where the slower thing created more heat and lost its energy, nor will they show me how the lighter thing, you know, has more energy. You know, it can do more work. Don't forget, if you are looking at proportional increase in temperature as a measure of average kinetic energy, you must be measuring in Kelvin. So again, more shit where the guy asks for the evidence and this guy tells him how to do the experiment. Just hilarious. If anything I've said is inaccurate, proper investigation of the above will reveal the truth. Oh, isn't that a great statement? Proper investigation of what? Of your many bloody experiments that you bloody did that you can't show us? Okay. No, you're going to fail right there. Right there. Your statement that we see it bloody all the time. No, we exactly see the opposite bloody all the time. We don't see a single professional bowler being able to gain any of that extra energy. Somehow they're too retarded, too dysfunctional to throw a 12-pound ball and get 40% more pins. 50% actually. 50% more pins. Just throw the 12-pound ball and get 50% more pins. And somehow none of the pro bowlers can figure out how to do it. Sure they can't. Yes, easy. Okay, so again, there's no links here. There isn't going to be any freaking experiment again. Without any thought experiment or without using a proof based on mathematics. Okay, here we go. It is in the braking distance of a car from a certain cruising speed. So we're not going to have any evidence of this one either. There's just no evidence of this theory that it's more energy because you, again, are braking disproportionately. You're taking a heavy mass and having the same size brakes as the lighter mass. You can't do that. You can't give them that kind of disadvantage. All right, you're just playing a game with friction. Okay, so again, it's got a huge built-in bias, and they're just pretending it's a fair experiment. No, it isn't. Okay, in general, when your cruising speed is double, your braking distance will be squared. And again, this just has to do with how friction works. The faster you're going, the less friction there is. I mean, that's just the way it works. Speed often degrades how well friction bites. Friction, most things that cause friction cause it disproportionately to slower, heavier things. They are affected more by friction than light, fast things. And you can just think about like water. Boats on water. The fast boat hits less of the water. Okay, this is because all the kinetic energy of a car has been dissipated by the more or less constraint braking force in order to overcome the standstill. So that's your theory, but that's not the reason. The work delivered to the braking process is by definition braking force times braking distance. And again, it has nothing to do with an experiment that's going to give you the right result. This has everything to do with being smart enough to know that, yes, there's a bias for fast things. Fast things evade friction. That's the underlying truth. And they're pretending they can't know that. So he's just doing all this braking distance thing. So again. All right, let's see. So that doesn't, like I said, the braking distance of the fact that the most ways you're going to collect energy where you're going to rely on friction will have a huge bias for the lighter object because gravity is pushing the heavier object harder into the ground. The heavier object's collecting more downward force from gravity, and the downward force from gravity is creating more friction. All right. So anyway, stupid. I've been thinking about this for a while, and there might be an easy demonstration for you to do at home. Okay, so let's see what this one is. Take a filled bottle of water and poke 3 holes in it with a push pin of adequate size. So this is again just a gravity experiment. Yes, we know how that well, I mean, whatever. Let's just go through it. Take a filled bottle. Try to evenly space the hole such that the middle hole is 2 times further from the water line and the top hole, the bottom hole, blah, 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 like this. So again, so now he's saying how much water pressure there is somehow proving that the kinetic energy theorem is correct. When obviously you could just see there's less water pressure here, and a lot more water pressure here, and a lot more water pressure here. So, you know, that doesn't do it. Alright, so there's really no point. How many of these did they? How many are there? Some great answers and some not so good. Let's eliminate some. It's defined that way. No. It comes naturally from the law of conservation of energy. Well, we understand it's really conservation of momentum. Because there is no such thing as energy when you're going to say there's kinetic energy. There's no such thing. And it turns out that when another form of energy is transformed efficiently into kinetic energy, so again, what another form of energy, this is just too silly. All there is your energy, and your energy is your momentum, or your energy is your kinetic energy. It has to be one of those two things is the right answer, and one of them's the wrong answer. Okay, dropping a ball into clay and measuring the dimples. Okay, so we're right back to 1728 or whatever, and you know, the silly rich people physics, where you don't understand that clay has a bias for velocity, that faster things go further in clay. It has nothing to do with having more energy. It just has to do with the fact that clay yields to fast things, just like your flesh yields to fast things. It's not a good way to collect energy. So that guy fails big time in the historical context. I didn't realize there was so many of these. Maybe I'll just do this later and see if there's... So we already know there's not going to be any answers that contain a link to an actual experiment. So no experiment. Look at all of this. No experiment. Exactly doing what nobody wants is all these fake formulas. Blah, 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 blah. No proof. So, woo. Hopefully that's enough. So there's no experiment. But that's, you know, all you get. And you got 39 ups for providing no experiment. Nothing. No physical, real experiment demonstrating mv squared. 1/2 mv squared. Nothing. No proof. No evidence. Just a formula again. You know. Okay, let's see what he says here. Asking for experimental evidence is, of course, what physics is all about. Hilarious. Most importantly, further, I like to put forth what actually might be the first law of experimental physics. No experimental evidence without experiment. Huh? No experimental evidence without experiment. No experiment without setup. I don't think this is the first law because it wouldn't be written that badly. Experiments have to be repeated, there you go, conducted in reproducible fashion to collect experimental outcomes. No, to verify outcomes. But anyway, he didn't write that very well. The critical question about kinetic energy is then, total energy being constant, how to increase it. In the first place, we have to agree on constant total energy. That is mandatory, by the way. I don't think that makes any sense either. Actually, just these days we have very resourceful North Korean dictator experimenting with this, toying with his ballistic missiles. Oh, what the hell does he have to make this into some political rant? With the world watching and the media recording, we should get our hands on some data and see if this allows us to hold to Newton's laws. I mean, just amazing core shit. Obviously nothing done in space has anything to do with this mv squared horse shit. All right, but your question only makes sense if the term kinetic energy is first defined. It's just amazing. It's defined by a formula, shithead. And if you define it in the way one normally does in introductory mechanics, then the equation becomes tautological, like asking whether there is evidence that a bachelor is unmarried. So this is just too pathetic. Okay, yeah, it's too pathetic. Oh, man. Yes, one experiment is compared to minimum braking distance of car. So again, they're doing the car thing, and again, it has... If you believe that friction is the same for heavy things as it is for light things, then that might mean something. But otherwise, it doesn't mean a goddamn thing. Alright. So, let's see. I guess I should say fast things. So anyway, so yeah, we're back to clay. Okay, so we're right back to the clay experiments, as if clay is a very good way to measure energy, when it's just a fact that the clay will always yield to velocity. Fast things will go further in clay. Alright, so no experiments, no experiments, no experiments. No links. There's just a ton of this stuff. Jeez. Alright, well, I'll come back to this, I guess. Such. Maybe start at the bottom and work my way up next time. Alright, so anyway, enough of a video. And such. And so forth and whatnot. Alright, yeah, I'll do the ending. Okay. This has been a DraftScience video presentation. And such.